Hey there students, welcome back to Pacifica Science. If you check out, we're in the home studios today. Pacificascience.org is the website, and if you look at this silly contraption that I have set up here, your video today is a little bit about what you'll need this week, a little bit about review preview, talk a little bit about last week and where we're going this coming week, and what you'll need to follow on with the home experiment. You don't need anything this complicated at home. I'll show you exactly what you need. If you saw the last video, it was just kind of a get to know the teacher type of thing. I went a little bit into just high school and going over at Cappuccino High School, some of the math that you need if you want to be successful at the physics, the chemistry, the engineering, and even if you don't go into those subjects, even if you go into, say, business or art, I would argue the math is still incredibly important. Math is one of those subjects that it was really part of my motivation for going into teaching. I love the science, I love the physics, and I actually had to spend some time kind of backfilling my math knowledge so that I could do those classes, I could do the physics, I could do the chemistry, because I really get stuck on a lot of things, and I want to make sure, part of my big motivation for teaching, part of the reason I love teaching, I want to make sure that when you guys get to 8th grade, get to high school, that you're looking at the classes not like, oh gosh, I have to get back, up to speed on the math. You're ready to go and you can say, hey, you know what? Give me more of the content, give me more of the science. I'm ready to go because I know how to set up the basic problems, I know how to set up the basic equations. All right, so let's jump into last week. Last week we did a little bit, week 1, on the moon observation. Kind of a tough week around here for a moon observation. It's very hazy with all the fires going on in the state. But we could still see the moon waxing. That means getting a little bit bigger every night. Went from a crescent last night, saw it, it was a kind of reddish orange in the sky here in Pacifica, but it was a waxing gibbous, we call that. If you looked at the moon getting larger, where we usually go when we ask students to do this is to predict, and about how many nights do you think it will be a full moon? So based on the pattern that we're seeing, and again, pattern recognition, really important in biology, really important in the sciences, in engineering. You want to see where is going and where do you think it will be based on where it's been. Also, a little bit on the plus deltas, we call them. The pluses are the things that worked out well. The deltas are the things that probably need some improvement. One from the week, a big plus, the students, you guys are awesome this week. So thanks for the pictures that I got from you. The advisory class did those great 6-word keys to happiness. I'm going to post those so everyone can see them. A couple other things just went really well during class. Deltas, those are things that need improvement. These are all from my end. One is I will print the notes. If you can't see the board behind you right now, again, this is really just so I can kind of remember what to talk about. But if you can't see the notes, remember, I will put them out online, but usually I use cursive. I think because we're doing so many notes online this trimester with the distance learning, I'll do printing from now on because I think it's much easier for a lot of students to read, especially the scan quality that they go in on. Let's see, one other thing was, oh yeah, please sign in with your name onto the Zoom accounts, your full name on the Zoom accounts. It's partly for me to take roll, and partly because, just like I'm doing right now, I'm looking at a little screen from kind of far away, and one time during last week, there was a student that was admitted to one class that was not in the class. It's happened before with other teachers. First time it's ever happened with me, actually, but I saw that later on, so next time I'll know, okay, make sure you only admit people that are, actually on the list, and I have them right next to each other against the screen. Other than that, I think the content last week was straight out of the first part of our CPO online PDF book, so check that out. Our reading assignment last week, pages 1 through 10, well, HW for homework, I went through that in a previous video. This week will be pages 11 through 23. This will go along with our experiments this week. For our experiment this week, this is the reason I'm making the video, all you need at home is a string. This is just a kite string right here that I'll show you up close. And 2 objects that just have different masses, different weights. One other thing that would come in very handy, and I know you have this at home, is a ruler. I used for my masses just something out of my socket kit right here. Get a couple of different size sockets, and you can tell very, very easily which one is heavier, which one is smaller. They're all made of the same material, so the larger they get, the heavier they are. Again, I'll get to these weights here that are hanging on the ropes here in just a second. Couple of other things very, very quickly. We started talking a little bit about the chemistry that we'll need for the class, just a little bit about atoms. We'll go a little bit more into detail about atoms and molecules. If you look up here, we went through the 4 forces, the 4 what we call fundamental forces of nature. Now, people talk about forces all the time. For example, right here, I've got tension in this rope. Tension is a force, and it's a pulling force, but if you look at forces, we might talk about centripetal force or centrifugal force. These other forces all result from these four fundamental forces. The strong force, the electromagnetic force, or electromagnetism, I should say, the weak force, and gravity. Again, that was part of our notes last week. That was something to write down, and it's going to be very important because we'll be talking about these four forces continually through the year. Remember, your interactive student notebook builds on itself. So that was one thing I did ask students to write down over the course of the week. Remember, I try and keep all the notes updated at pacificascience.org. Okay, our home experiment is going to involve this. And you can make a prediction based on what we did last week, a little bit talking about Galileo, a little bit talking about Aristotle. If you look at this weight versus this weight, the green rope that I have hanging here has a, let's see, a 3-pound weight on it. Little just home weights that I have lying around right here. The orange rope right here has a 5-pound weight hanging on it. And if you look at the top, I won't take the camera and pan up, but they're hanging from the same beam in my studio, garage really, but it's hanging from the same beam in the studio from just a bike rack. Front tire, back tire would normally be up there on my bicycle. Right now, I've got a couple ropes hanging there. Why? I want you to make a prediction based on what you know. And if you're looking also at variables in experiment, this is a great way to start talking about variables in a specific experiment. We're going to be much more specific about this experiment Monday, Tuesday, and then Thursday, Friday in the classes. But if I were to pull this back, this is just a simple pendulum, and let them go. Would the 5-pound weight swing faster, heavier weight? Would the 3-pound weight swing faster, lighter weight, easier to get it going, right? Would they swing at the exact same rate, or would they swing at completely unpredictable rates? In other words, given that these strings or ropes in this case have the exact same mass, and we can kind of not pay attention to the mass of the rope, it's very, very little compared to the mass at the end of it. What do you think would happen given controlling the variable of the length of the rope, controlling the variable of how far we pull it back, and then when you let it go, what do you think will happen when I let these go? If you look at the far right side of the board over there, it's just a picture on the chalkboard here of a simple pendulum, a string and a mass at the end. Sometimes in physics class you see this where they don't do it with a string and a mass, they do it with a spring and a mass. And it's got a spring that you pull it, and you can imagine it comes back with the mass and it keeps going again and again until it levels out. You can do amazing things with springs. We'll talk about springs specifically in class for all the physics experiments that you can do with springs. But our first experiment, Monday, Tuesday, is going to involve changing the mass at the end of this rope. What do you think will happen when we change the mass, the weight at the end of the rope, keeping everything else equal, keeping the length of the rope equal, keeping how far we pull it back? The next one we're going to do is we're going to fiddle around a little bit with the length of the rope itself, or the length of the string in the case of your home experiment. These are variables that we can manipulate in the experiment. We want to just manipulate, we want to change one thing at a time, see what happens. So, quick recap, a simple pendulum is just a mass swinging on a string, or swinging on a rope in this case. Does it make a difference if it's a 5-pound mass hanging, or, hold on, a 3-pound mass? Will it go faster or slower, or will it not make a difference depending upon the mass on the string? I'm not going to do it for you yet because I want you guys to try it out for yourselves. That's where we do the engineering part of the class. This is where we figure out at home how to make a simple experiment. Again, something as simple as kite string and a mass at the end of that string. Have a great day. Looking forward to seeing you all online Monday, Tuesday, then again Thursday, Friday, and then I'll see the advisory class on Wednesday. Take care, everybody. Happy weekend. Bye-bye.